Accurate and updated national foundation location data plays a pivotal role in our modern world. Integrating it with existing systems can empower decisions, improve customer experience, and boost efficiencies. Today, our speakers will present use cases for foundational location data and how you can benefit from data as a service. They'll also demonstrate specific instances where location data has been used to extract robust and actionable insights for the insurance sector. Our first speaker will be Michael Dixon. He's the Chief Data Officer at Geoscape Australia. Michael has more than 20 years of hands-on experience in the geospatial industry and has led technical and commercial teams and has a deep connection to national foundational geospatial data sets and related services. Our second speaker will be Pravesh Connor. He's Principal at Affinity Consulting. Pravesh leads Affinity's geospatial practice and is heavily involved in helping companies use external data and geospatial insights for analytics and business strategy. And so with that introduction, we'll turn it straight over to Michael Dixon to begin his presentation. Thank you.
Great, thanks for that, Jonathan, and welcome, and thanks for joining everyone. So thanks everyone. Appreciate you spending a bit of time with us this morning. I guess on the background, the star of the show was absolutely Pravesh Affinity later on, but I'll give you some information about the background, almost the what, where, and why of foundational data before we get into the showcase of a particular use case. So to begin with, I think it's worthwhile providing a background on Geoscape. We're an organisation that is owned by the 9 governments of Australia. We created as a commercially operating for-profit company. In its current form, it was created in 2001. There is a statement of expectations that the shareholders, being the governments, provide for the organisation. And that really sets the scene for how we operate. And so as an organisation, you may have heard of PSMA Australia. That entity still exists, but we trade as Geoscape Australia, and that change commenced in 2020. So I think that's helpful background as we have the conversation. So I'll start by talking about what is foundational location data. And really, I think the terms have started around 10 years ago, but it really gathered a lot of momentum when around 2017, the United Nations Committee of Experts on Global Geospatial Information Management, a bit of a mouthful, started to consolidate what it meant to have themes of spatial data. And it's arrived at this notion of 14 fundamental geospatial themes, and I think placed best in an extract from the communique associated with the event that really drove home what these 14 themes would be. And it's really around the minimum primary set of data that can't be derived from other data sets that are required to spatially represent phenomena, objects, or themes. And the reality is that these data elements help us assess and manage economic, social, and environmental benefits across, in this instance, it was Africa, but recognised globally that these elements are important for the way that we manage information. And so it's this sort of tangible information that helps measure, monitor, and manage sustainable development goals. And fundamentally, all of this information helps deliver better services for people, and it helps with this notion of evidence-based decision-making and supporting policy development and the like for government, so and industry alike. Where does foundational data come from? Well, fundamentally, it's come from the governments of Australia. In Australia, in the context, I'm sure people are aware that we really have 3 lawmaking bodies, starting with the local councils, around 550 local governments in Australia. And so they make a lot of local laws, bylaws, but they manage and administer a lot of land-related information, and that forms an important base when it comes to foundational information. We have our states and territories that bring together a lot of information from the local government, but also enrich, run a whole bunch of administrative processes as well. And then we have the federal parliament and federal laws and information that supports the implementation of all of those laws happen at the federal level as well. So when you break that all back down, We start with very high quality data, and the surveying industry are fundamental in the creation of all of this foundational data. So we're talking about survey plans, deposited plans. These are the plans that help describe how the land around land titles is changing. But then we move from those, which is a very highly regulated industry. And so we have high quality cadastral surveys and cadastral plans, and we administer lots of functions like the electoral process with high quality, well-regulated information. But as we move further along the spectrum, we end up with, I guess, more of a cultural, almost in-use flavour of information that is still part of that foundational data suite. Along the way, there are important government functions around place naming, and you can see an example there where in the ACT, there's an official process within the Division of Taylor to recognise names. And these are names of features like the road network, but it could be a park, it could be a suburb. There are official processes that are run, the information is well recorded, and it's fundamental in the way that the community talks about place and location. And so these sources are important, and that manifests itself in lots of different ways across different survey plans, different documents or instruments that drive our understanding of the built environment and the landscape and as it changes. But it's not just about government data. Technology's played a massive part in the last few years. And I'd argue it's starting to disrupt what we've traditionally viewed as foundational data. So terrestrial surveys where we can capture lots of information at scale now around the location of the road network and features associated with the road network. But it's not just terrestrial, it's also airborne information. We're talking about satellites, we're talking about planes, and increasingly we're talking about drones. But these things enable us to capture a very accurate representation of the real world at scale. And for Geoscape, in terms of buildings and the built environment, the satellite platform was the information source that enabled us to build out a national view of buildings to begin with. But there are higher quality sources of information, of course, so LiDAR information. So there's a representation of the Washington CBD in the USA. LiDAR can be extremely accurate information, again, remotely sensed information, and it helps build a very accurate picture of the built environment. We're all capable and we're all connected nowadays with mobile phones. And so there is another sensor that we're talking about when it comes to possible foundational data sources. And if you start to layer on the world of the Internet of Things and all of the different sensors that are available, we start to build out a really interesting view of what it means to be a foundational data set. There are important building blocks that come from government, but there is lots of other data that can go around it to help describe information and make it more valuable for business and a lot of different use cases. And I guess playing that out in terms of where we're going, the market and I guess the whole ecosystem is evolving rapidly. So generation one of the building representation data at scale. So remember, we're talking about a national scale, 15 million plus buildings. And there was an enormous effort and I guess an internationally recognised effort in Australia to be able to build out a data set at scale of this quality. But use cases that need higher quality representations of data are not necessarily supported off the bat. So we talk about how the information is improving, both in terms of feature recognition, improvement of representation, and indeed the ability to capture extra information at scale now. And this really forms part of the foundational data suite that's available to be used in lots of different applications. So we end up with this foundational set, a national data representation that picks out aspects of the built environment, whether it be a building, a pool, a tree, even a road or a pavement. And we're starting to see that these foundational data sets linking in with government data, and you end up with this ability to create really well represented and connected information sources that can empower business in lots of different ways. So the foundations that are set by the governments and the work that happens with the surveying industry and the spatial professionals and the spatial industry means that we end up with lots of high quality information that both government and industry can start to utilise in lots of different ways. But there's still an element of curation that's important. And how does it all come together? Well, for Geoscape, the approach is fundamentally based off 4 principles. There's lots of information available, and so sourcing that information to try and relate back to data custodians, it's the right starting point. So again, building off what happens with governments, start there and work through the creation or sourcing of information that we can then aggregate and create these national representations. So processing, I'll show a few examples of what it means to process in a minute, but lots of different enrichment activity goes on by creating all of the, not only harmonising data to standards, but then linking, improving the quality of the representation, and then delivering in a variety of different ways to enable different consumers to consume in a way that makes sense for their business. So in terms of examples of what it takes to build these data sets for addressing, and particularly for the geocoded national address file, the first step is really trying to align information to a common vocabulary. So you can see, I think, 16 different elements of an address there. And so there are lots of ways of representing addresses, but for a national approach, we need a common platform, a common approach to being able to build out a representation. And so that's the first stage. But there's a whole bunch of official information when it comes to addressing. And there is in-use information. So addresses are cultural, people talk about them in different ways. And so as service delivery organisations utilise address sets, they start to need to build out a slightly different version of the vocabulary to be able to deliver the service at scale. And we, through the GNAF production process, create a blend of the information to I guess, create the data set. And then the third stage of this enrichment is really looking at ways of trying to take the base information and tailor it to improve market fit. And so the example there is effectively this notion of a paper set of information. So something was planned, the development's not gone ahead. However, the legal information, the legal instruments, the jurisdictional information reflect an environment that's not there for people to interact with for many different use cases. So being able to create metadata to support the use of the information. So other common challenges, and in this instance, we talk about the road network, disconnected features. When the features are all created and used in the context that they were generated, they're fine. But when you start to place them in a national context, we need to work through some enrichment. Now, these things, you can just see an example there where these disconnected features would create a challenge. And so part of the activity that Geoscape delivers is this process of continually representing or seeking to improve the standards when it comes to spatial features associated with the road network. The ongoing value, of course, is that this happens in a repeated way. It's I think it's probably analogous to this idea of a marathon that never ends. We're working through this production process month on month, quarter on quarter, year on year, and over the 20 years of the organisation, we've been able to create data assets that have stood the test of time, and people are able to invest and utilise in a way that continues to add value to industry and government alike. So in the case of a roads monthly release, you can see that we ingest quite an amount of information. There's a standardisation approach. We're generating a different product which has some delta notions associated with them so that people can just focus in on the areas of change, and then it's delivered in a way that links in with the needs of a particular organisation. But as a service, we're changing, the world's changing. And the processes of the past where I think the PSMA era of national foundational data was very much around this notion of creating a standard data theme and making it available in a way that I guess really only enabled organisations with capability, and it was pretty niche capability to be able to take the information and utilise in their business. And that generated, I guess, an enormous industry of organisations that help tailor information to particular end users, but it also created a lot of duplication of effort. And the reality is now with technology, we're able to start to engage more closely with use cases, verticals, and end user organisations and tailor the delivery of information assets directly to their business. So foundational data has moved from being a data set that sat on a shelf to one where we're able to customise information and deliver it to the end user in a form and a structure that meets their end user need. The tooling that sits underneath that is, I guess, notionally referred to as a continuous data platform. It enables the idea of being able to operate at scale, and that's an important element to our operations. We end up with multiple data sources. We do this processing, enrichment, extraction to meet the user needs, and then of course the delivery services that sit over the end of it. And for our organisation, we've utilised that data across, utilised the process across a suite of standard foundational data, and that same capability is available for all other organisations to make use of, specific to their business needs if needed. What are the benefits? The benefits to the user community are really around this idea of being able to create applications that scale. So you can start local. You've got the high quality representations of data that start with local government and smaller, even feature level representations. You're able to really focus in on the capital, the gains that you can make by not needing to take all of the data at exactly the same time. So previous models really incentivized whole of country approaches to getting access to data. It's much more tailored and nuanced and focused in today's terms. The data, it's really accessing only the data that you need to power your business. And the idea is to let data not be a project anymore. So we've all been in circumstances where we've had to deal with data and sourcing data, and that's taken up a lot of time and energy when really your value add is around the utilisation of this information to improve decision making, to deliver more focused services for your customers, to participate in a digital transformation. And the data shouldn't be the project. It should just be available to you as you need it, when you need it, in a form that you need it. And so the idea of creating these different ways of accessing this information is really around trying to enable you to deliver the insights for your customers needed at scale. So how do you get access to the information? Well, as I said, there are lots of different use cases that the information supports, and we are going to dig into an insurance use case in more detail pretty soon. But the information is able to support many different use cases when we talk about risks and climate change, when we talk about retail and understanding where customers are, where they're moving from and to, information around transport and logistics, which is the same notion of the start of a trip, the end of a trip, the fastest way to get through a trip. Foundational data helps deliver all of those important value elements for the community. In terms of how you get access from a Geoscape standpoint, well, there are lots of different modes of access. Some there's open data. A lot of foundational data is open data, but there are challenges in utilising open data as the value starts to emerge when you can conflate it and create harmonised data sets. And that's not a straightforward exercise if you don't have the expertise. Increasingly with technology, There are APIs available now. These APIs operate at scale, and that works really effectively for being able to deliver web-based applications, for instance. You're able to license data directly from Geoscape Australia, and indeed through some partners. And in many instances, there are products that are built over this data that you are able to license and utilize as well. And again, we'll see one of those examples today. But fundamentally, from Geoscape, it's a pay per use model. It's a paid model. There are commercial service standards that underpin all of the data. So I guess one of the differences between an idea of open data and a commercial model is that there are commercial service standards and service levels that underpin access to this data. And finally, there's the addition of notions of flexible access and support. So accessing the data as you need it, and the support from our technicians and I guess experts that can help you get value from the information that you have at hand. That's my part of the conversation. I look forward to questions, and I also look forward to you seeing what Affinity has. And Pravesh, over to you now.
Cheers, thanks, Michael. I'll get you to stop sharing your screen if you don't mind. Thanks. Just a reminder to anyone, if you've got any questions along the way, please use the Q&A function, and we'll look to answer those later on after I've finished up. But thanks, Michael, for the introduction. I'm just going to share my slides. So I'm Pravesh from Affinity. Affinity is a leading strategic analytics firm that have been working with Geoscape for a number of years. Our journey is quite a long one with using geospatial and location-based information. It started around 10 to 15 years ago when we first started building our natural perils pricing models. And that's really evolved over the last few years, and it's expanded out to using some of those foundational data sets that Michael described earlier. And we've now been a partner with Geoscape for over 5 years. And really our role is to use the foundational data and apply analytics over the top of that to develop specific solutions for our clients and help support their strategies. So I'm today going to talk a little bit about how we use that foundational data, and I'll provide some examples of our products and solutions in the insurance space, and hopefully that'll help everyone think about how this could be applied across other industries as well. So I've got a few slides to take you through, and then I've got a little demo to hopefully bring it to life a bit more and show you a little bit more about our solutions. So I just wanted to start off by putting in context some of the data, the foundational data that Michael talked about, and how that feeds into what we deliver to our clients. So we use a number of the Geoscape foundational data sets, and they're listed at the top of this slide. So, so many of which I'm sure the people here will be aware of. So GNAF, obviously, building information, so outlines, solar panels, pools, and the like. Cadastre and property information, so land parcel information, tree information, so tree coverage and height information, the road network that Michael talked about, as well as administrative boundaries. And essentially what we're doing is taking all these data sets, linking them all together, adding other external data sources together, and applying our geospatial analytics over the top of that to essentially produce a range of address level data sets and use cases. And so I've got 3 here, so fin point, fin perils, and some bespoke use cases. And I'll talk a little bit about those in the coming slides, and how we help our clients embed them into their BAU processes. So before I do that, I just wanted to talk a little bit about how we help our clients and how we interact with the foundational data. So we're not, we're not the people that produce the data. We work with the data to draw out the insights for our clients, and so that's really about understanding that information, so cleansing it and linking it, as I mentioned earlier, understanding the data quality, and enriching the data with other external data sources where needed. We've invested a lot of time in doing that, and it's really about converting the spatial data into data sets that can be used by the end user for various purposes, for example, pricing and analytics. And linked to that, we've developed insurance-specific risk measures that aim to use that spatial data to target specific use cases. So I'll talk a little bit about the risk scores that we've built that insurers use. And finally, as part of that, it goes beyond just building the scores. It's helping actual end users and companies actually work out how to use them in their systems and their algorithms. So taking this information, embedding it into their systems and making sure they can get ongoing use out of it in a BAU process. So I'll first start off with the first use case, which is around pricing and underwriting for insurance and a product that we have called FinPoint. FinPoint offers building and location data on demand. It's a suite of data products which enable end users to deep dive into key information about a building, its geographic surrounds and address risk. I've categorized it into 4 sort of different segments, which hopefully can describe it a little bit more. Obviously, the first one is buildings information. So that covers a lot of the foundational data elements that Michael talked about from Geoscape. So that's building area, heights, roof, solar panels, swimming pools, and the like, which really let end users understand the physical asset risk and characteristics. There's also information about areas. So that's really about features at or around the address. So that might be certain information about the street that address is on, how remote that property is, as well as socio-demographic information about the surrounding area. Then there's features of interest. So that's really about points of interest around a certain address. So we're talking here about schools, fire stations, shopping centres, road information, etc. And then we've got these risk scores, which are essentially a range of risk scores about an address. So what we do is we'll take the 50 to 100 features about an address, and we build a risk index around that aims to predict the level of riskiness for an insurance context. So that might be a tree risk score, a motor risk score, or a theft risk score. And I'll explain a little bit more about the tree risk score on the next slide. So we have built a tree risk score, which essentially is an address level score for each address in Australia, and that will predict the level of tree risk at an address. And that's essentially, you think about it, the risk of tree damage or a tree falling on a property in the case of a storm event for insurance purpose. So we use the foundational data quite heavily to draw out insights in this space. So we use detailed tree and building information. So that's really about tree location, tree height, building location, the distance between those and the direction. We then combine it with other external data, information about the climate and wind direction, as well as shielding information. And what we do is then build a risk score around that. So the image here shows that the top image here shows the satellite view of an area in Sydney, and you can see it's a fairly residential area with buildings and a pretty dense sort of tree environment there. The bottom image shows the results from our tree risk score. So the green pixels here identify trees, and obviously the darker the green, the more dense the trees are and the higher they are. And then you've got all the buildings there in that image as well. And that and the more red the building, the higher the risk that we assess. So you can see how each building or each address has quite a different risk profile, and that really is a function of where the trees are, where the buildings are, there, and then the direction they are sitting in relation to dangerous winds as well. So it goes to show how you can use that foundational data to really solve a pretty complex problem through using some pretty sophisticated algorithms and analytics. The next one I wanted to take you through was another use case for pricing and underwriting for insurance, and this is FinPerils. So this is FinPerils is our suite of natural perils risk models built for pricing for home insurance, for example. And so this suite includes a range of natural perils models, including bushfire risk, storm, flood, cyclone, and coastal erosion. So essentially, we have for each of the 14 or 15 million addresses in Australia, we have a risk score for each of these 5 perils that tell you the riskiness for that address. So we use a range of industry-leading approaches to do this. We use the Geoscape data plus a range of information from a variety of external data sources, such as the Bureau of Meteorology, to model the risk of each peril at a specific address. And we use a range of machine learning techniques and algorithms to do that. One thing that's quite important to note here is that these are specifically built and relate to the Australian climate. So they really consider the specific science to model the drivers and outcomes. So the last two slides that I went through really talk about the data sets that our clients use on an ongoing basis to help them with pricing and underwriting. We create solutions to address bespoke problems for clients. So I've got a few examples here where we don't necessarily have a product, but it's more about using the data in a sophisticated way to answer a specific problem that a client might have. So if we start at the top left here, with COVID-19 motor risk. So clearly with COVID-19, there was lockdowns throughout Australia. It meant that people weren't driving as much on the roads. And so we used information around mobility to understand the reduction in, or the impact of the lockdowns on congestion on the roads, and therefore the reduction in motor insurance claims during the pandemic. And so that helped the industry understand the impact from a claims perspective as well as a pricing perspective. Through COVID-19, we also did risk modelling to help State Department of Health in Australia in understanding its COVID-19 transmission. So this was really about using information like building information to understand the footprint or the movement of people indoors versus outdoors, and therefore modeling the transmission risk with a whole bunch of other external data sets. And that really helped the State Department of Health understand the potential transmission as the economy opened back up, and then help them embed strategies to manage that transmission through the course of the last couple of years. Recently, we also helped, we used the Geoscape data and other address level insights to support the establishment of the Northern Australian Cyclone Pool. So for those that aren't aware, that's a new insurance pool that went live 1 January this year. And it's really about trying to provide cross subsidies to properties in Northern Australia, which are cyclone prone and have some pretty serious issues around insurance affordability. And so we used the geospatial data as well as our analytics to identify the exposures to these sort of perils and model some of the outcomes and some of the costings that help support setting up that pool. And so that was quite a relevant piece where the geospatial insights and data really came into great use. And then finally, with the natural perils and climate change models, I talked a little bit about that on the previous slide, of how companies use those sort of models to essentially price for home insurance. And that's one of the main use cases. But there's a range of other use cases that we've helped our clients with. And so one, for example, is to understand the home insurance affordability issues in Australia. Clearly, there's a lot of places in Australia with high cyclone or bushfire or flood exposure, and that presents a real affordability issue in Australia for home insurance and a real social issue. And we recently produced a green paper for the Institute of Actuaries that really delved into those issues and used the natural perils models to identify the key areas of exposure in Australia where these issues are really going to arise and the impact of climate change on that. We also use the natural perils models and climate change models to help banks in climate risk assessment. So, an example would be for their mortgage portfolios. So, for a bank, it's important, for the hundreds of thousands or millions of mortgages they've got in their book, understanding, well, for the mortgage portfolio, what sort of natural perils risk have you got on your portfolio at the moment? And how's that going to change in 10, 20, 30 years time, 50 years time with climate change? And so we have models that not only estimate the risk now, but what it will look like in the future. And that can really help in understanding the portfolio and managing it going forward. I've now got a demo of our solution. So this is a visualization of some of the data sets that we provide our clients and they use for analytics that will hopefully bring some of this information to light. So it's off our Affinity Central platform, which will hopefully will demonstrate some of those information. So we'll start off by looking at an address from our platform. So we're just going to search there, and it will cleanse that address and find that on the map. So you can see there that pin there on the map is the GNAF, and we'll then zoom in a little bit more, and we can have a look that there's 2 buildings there. So we've got the residential property and then also a shed out the back. And you can see some information on the screen there around the GNAF information, some information about the buildings and and building height, roof material, swimming pool, solar panel, and the like, which is some of that foundational data that Michael was talking about. Here's an example of bushfire risk. So we'll type in an address here, which is bushfire exposed, and you can see it's quite close to some pretty dense vegetation. We can see here we've got flood, storm, cyclone, and bushfire scores. You can see the bushfire score here and how that changes over time. If we delve into that into a bit more detail, we can see our projections of those bushfire costs under different climate scenarios. So an RCP 2.6 versus an RCP 8.5, and how that's going to change up until in many decades time, as well as how those drivers of risk emerge. So the distance to vegetation and other regional climate factors. I've also got an example here for flood, which is quite relevant, obviously, with the recent floods. Here's an address in Lismore, and then we'll pull out a heat map which shows you the distribution of scores within Lismore and how the risk changes by, and that each of those dots is an address. And then there's a high-level heat map here to show you how the risk changes within a certain area. I think we're going to cater for the people that are colorblind, and we've got some different contrast of the colors, but hopefully gives you a bit of an insight about how the risk changes by address and how we can use this sort of foundational data to really pull in analytics and really help businesses solve some really complex problems. So hopefully you found that interesting and gave you a bit of insight into how we use that data, and that wraps it up from me, and I'll hand back over to Jonathan.
Thank you very much, Pravesh. Those two presentations were really fascinating, and I've got a bunch of questions of my own, which we might start with, because while they're top of mind, I noticed you showed there, Pravesh, some of, like, Lismore is a regional centre, and it's got rivers and things and lots of bush around it. I was going to ask Michael, can you describe the sort of data that is captured, in the sense of, does the database have every building, every shed, every pool, every road, everything in Australia? What is the extent of it?
It's a yes and no, Jonathan. The reality is there's to do this work at scale, there is a currency lag in some examples. So the idea of having a shed created today and then using remote sensing to represent it in a data set tomorrow is not realistic. The reality is there are refresh rates that vary across the country from a building representation data set. I guess example standpoint, for the country, it took around 3 years to be able to, it took 2 years to be able to build out the data set initially from its prototype, using a catalogue of around 10 years worth of imagery. So it wasn't, I guess, instantaneous, but the processing cycles now are much richer and much more capable of creating and dropping data in the same quarter. And indeed, for addressing information, the currency is really at a daily refresh. So it's across the different data themes. There are different levels of freshness that you'd expect in the data. So some of these things at scale are not yet mature enough to be able to do, say, the entire country every day. That's not realistic. But when it comes to addressing and working off the back of land administration, that is a daily exercise today.
Okay, so we understand that there's a cadence in the updating of the information, but as from whenever the information is sort of settled, we take a particular date. Does your system classify the different items, or does that have to be done by the user? So if I plug into your system, does it say, can I say, show me all the sheds, or show me all the trees, or show me all the buildings, or whatever?
Another good question, Jonathan. The classification of the feature, it doesn't happen at that scale. There are models that people are using. Affinity obviously have a model that takes the different representations. Perhaps it's based on size for residential properties. It might be based on the number of vertices. There are techniques that organisations use to try and classify individual buildings. There are lots of classifications that then occur at scale across some of the other data using the enriched information that comes through a government process, like a planning scheme. A planning scheme is a way of classifying land and land information, and that information is available at scale.
Okay, great. And just following on Pravesh, before we get to a couple of other questions, I mean, we focus a lot on the sort of urban areas. So, but if I'm a local council in a regional area, or I'm a farmer, and I'm worried about bushfires or floods and things, do you cater for those users as well?
Yeah,
Or can you cater for them?
Yeah, I think historically our models have obviously been, I mean, Affinity's background is in the insurance space, and that's kind of where it naturally tended our model. That's why we built them, but they're essentially risk models about bushfire risk. So they're kind of agnostic to necessarily, if you're interested in bushfire risk, it predicts the bushfire risk, and it incorporates all the physical asset risks around that address. So it can really be used across any sort of industry that is interested in understanding that information. And we do, whilst insurance is a key component because it's important for home insurance, it's not to say that it can't be used across many other industries, because it's effectively agnostic to the industry you're looking at.
Okay, in fact, we've got a question on bushfire. One of our viewers has asked, and this might be for you, Michael or Pravesh, where do you get the bushfire data from? Where does that come from? Who provides that?
Yeah. So I'll cover our model. So we have a bushfire model which uses many different data sets in there. So I wouldn't say it's necessarily one bushfire data set. It's a range of information. So, we'll use information from Geoscape around the tree information. Obviously, that becomes important. We use other satellite imagery and machine learning to estimate to identify where vegetation is in Australia. We use information from Bureau Meteorology on wind information. We use digital elevation models to understand the slope of properties. There's probably 10 to 20 factors that go into the model to predict the bushfire risk, and so it's really about understanding all the different sorts of external data and how you put them together to answer that problem about what actually drives the risk. So it's understanding the science behind it, and then using the data to use the data to model out that outcome.
Anything to add to that, Michael?
No, I think that's right. The bushfire data, there's probably two dimensions I'd think of immediately. One is perhaps the burn scar. Where did a bushfire impact? But that's a retrospective piece of information. That's after the fact. And Pravesh is really, I think, talking about predictive models, and there is no single flag, if you like, that would be a foundational data element today that represents that. That's really bespoke to the use case that's being serviced by the foundational information.
Okay, we've got a question here from Chris Boddy. He would like to know, how do your models interact with other models, e.g. in the insurance industry, and link up with jurisdictional policies, planning development?
So from a data perspective, Geoscape's very...
So planning obviously is important. People need to know where things are and when things are being built and where things are growing. So,
yeah, absolutely, it certainly is. I think the question's aimed at then, if there is a bushfire model, how might local government be able to develop planning policies to minimise the risks to the community of future impacts? And I think that comes down to the utilisation of information. And at the moment, I think the utilisation is probably not as widespread as we would like for some of this information, and that's really almost the point of the podcast, the webinar here, which is about saying that this information is available to be able to utilise in a more connected way across lots of different applications. And the demonstration from Affinity today is one of those ways. And whilst it's tailored at the insurance sector today, it's certainly able to be utilised in other industries and government as well to be able to answer and connect up really important policy and government decisions.
Yeah, I think I just echo that. It's the main use case that we've used so far for the bushfire model is in insurance, and that there's a pricing signal there in terms of home insurance premiums, but the better signal is to actually use this information to help plan out and plan out where properties go and really drive that risk mitigation.
Do it beforehand, in other words, yeah. We've got a question here from Charles Moscato. He's interested to know whether Geoscape is looking into technologies such as blockchain in relation to improving the currency of address information. He says that as a water utility, we create our own development addresses to apply billing charges earlier. which could be used within councils as a tick and flick, vastly improving the overall community costs associated with creating and maintaining address information. What would you say to that?
It's a great question. And Charles, I'd echo the sentiment that there are opportunities for us to be able to make use of technologies like blockchain to be able to improve the validation and, I guess, certainty when it comes to addressing information. I think governments as a collective will make some decisions around how best to utilise technology like that in the future. We have no active plan to be able to do that ourselves at the moment.
Okay. Just back onto the topic of bushfires, perhaps this is for Pravesh. Can you provide a BAL, a bushfire attack level rating? I'm not familiar with that term, but you might know it.
Yeah, we have thought about that. We've done a bit of research into the into what drives a BAL level, and effectively a lot of the building blocks in our bushfire model kind of in parallel to those BAL attack levels. So we can. Yeah.
Just back onto the utilities, just following up on Charles' question. So the Geoscape information there is all sort of surface level, above surface, and I'm just wondering for utilities who've got below ground things going on as well. Is there some sort of API, or can people build APIs that connect what they see above the ground with what's below the ground, where they need to dig or investigate whatever? If you've got a big tree, it's going to have big roots, perhaps. So utilities who do underground stuff might be very interested in this.
I would agree with that, Jonathan. I think there is an opportunity to bring together some more information about assets, for want of a better term, but it probably in a controlled way, and it might be more utilised in more specific use cases. I don't think there is a strong appetite to have a widespread access to all information about everything, if that sort of makes sense, because there are challenges in maintaining this information and disseminating it for, I guess, specialised use cases and integrating it with other things. There is no doubt that there is opportunity to, I guess, improve the level of access associated with underground utilities, as an example.
I remember talking to a council in South Australia a few years ago, and I'm not sure whose data they were using, but they used to have a manual process of just sending guys around in trucks, trimming trees away from power lines and things. And there was no real plan to it. But once they got overhead data, they were able to then optimize their route, and it saved them like a year's worth of effort. So I guess this sort of information would be very handy for that.
Most definitely. I think it's important when you think about how foundational data provides, I think, almost the context and reference frame and almost a backdrop in terms of where you need to focus your energy and resources. So I guess the tree trimming example is almost an example of service delivery at scale, and the idea of being able to focus your resources where you may have the most exposure or the most impact or the most need. Foundational data enables you to start to determine, administer, roll out all of these different services. And it's a really, really important way of engaging with customers, I guess, enabling your own digital transformation. And so utilising, I guess, LiDAR and other related information sources to help build out higher quality representations of features enables you to do that information at scale and plan workforce mobility, etc.
Okay. This question is for both Pravesh and Michael from Sharia Rahman. Michael, regarding your building data product, can you share the extent and percentage of coverage of the data set? Is there any public WFS/WMS service available to use the building data set?
It's a great question. The coverage is national. So I guess the data set created or started in 2018 when the first representations became available. We've built that out to cover the entire Australian landmass. There's a lot of work that goes into maintaining it. It's available as a commercial data set. There are APIs, indeed free APIs. There's a free tier of APIs that we make available, which allows people to get started to utilise that data. but there is no national scale web service that will enable you to interact with that data at the moment.
Okay. Another question from Michael. Would you take data feedback and what would be the process? That's an interesting question.
It is a good question. I think, interestingly, yeah, absolutely, we take data feedback all of the time, and we have a service desk that's dedicated to receiving information from the users of the data. The feedback's really important for Geoscape, and I think the industry in general, because I think it gives us a better understanding of how the information is being used. Is it of right quality? Is it fit for purpose? And so where there are issues or where there are improvements that could be made to the data, we'd love to hear from organisations that are seeking to make use of it and have information that they can provide about the quality.
Okay, and sort of a related question for Pravesh. So when people are then using your service, for instance, how do companies test the value of the data and the risk scores? How do they assess whether it's what they think it's going to be?
Yeah, it's an interesting one. That's kind of quite often when we talk to clients about using the data, they're like, well, how do we know it's valuable? And some of it will be, a lot of it will be trialing the data and kind of putting the theory in practice and seeing whether it holds up. So that could be sampling a small element of the data and testing whether it meets their needs, or it could actually be a wide scale modeling exercise to look at, well, I've got my portfolio here, and if I overlay the data here and I embed this data into the models, what's the sort of uplift that I see in any sort of outcome that I'm trying to measure? So, yeah, a lot of the, in terms of kind of making sure that there's good commercial value in that information, it really does come down to actually understanding what your use case is, and then actually testing it, rather than kind of just absorbing data for absorbing data's sake. Yeah.
And so, Pravesh, your company uses the services and data provided by Geoscape, as others can do as well. But you have customers, so your customers are using the Geoscape data via proxy, I guess. If you didn't have the Geoscape data, would you be able to provide this sort of service for your customers? Could you build it yourself, or how much would it cost you? Would it be worth doing?
Yeah, we could do it with a lot of time, a lot of effort. I think that's the benefit of having foundational data set providers like Geoscape. We can leverage out in that way and make it we can produce information. First of all, we can focus on actually producing insights rather than producing data, because we're not data experts, and I don't think that's the space that we play in. The space we play in is to use the data to actually draw out insights, and having that data available allows us to do that on scale and actually support a number of different clients, and so that prevents individual clients or insurers or companies having to do this themselves, and they can leverage off I guess in some ways a standardized process that then they can adopt for their own particular needs.
Okay, Michael, open data and open source and everything is a buzzwords at the moment, have been for a while, particularly in public service and public data. A lot of places all around the world, every jurisdiction is trying to get involved in this. So, I think you said at the beginning, a lot of the data you get is open source, and there are APIs, as you say, that anyone can use to grab the data. So, is open source really foundational to this foundational data?
Well, look, I think government policies all over the world are recognising the value of open access to information to be able to improve the lives of its citizens and deliver, I guess, programs that enable innovation to occur. But I think from the Geoscape perspective, there are a couple of components to the answer here. So our organisation does make use of open data. But it also makes use of commercial data and data that we pay for. In terms of a solution, open data, I guess, whilst it might be free to access, it doesn't necessarily mean there's no cost to get value from that information. And so there's part of the challenge, and I'd like to think part of the value that an organisation like Geoscape's able to deliver over the top of the data, where it's more tailored, it's more customised, and I'd like to think more fit for purpose for particular use cases. And I think open data doesn't come underpinned by service levels and the ability to necessarily put an entire commercial model around your business. And so open data is definitely a significant part of the ecosystem. Indeed, the geocoded national address file is available as an open asset and underpins many different parts of the economy, and we support that activity. However, I think open data probably needs, for business, a sustainable element to it, which is around making sure that it's funded, it's able to be improved, maintained, delivered, so that organisations can invest and know that that information asset will be there when they need it in years to come.
And I think my impression is that probably the public sector is way ahead of the private sector in the use of open data and having a mindset of using open data and sharing information. Do you think the private sector might be a bit behind on this, or is that just my bias on that?
From my lens, I think the private sector is not behind. I think they are making use of this information, particularly for some of the enrichment. But there is as I say, there's a cost of utilising this information, integrating it, managing it, blending it with other information, understanding the quality dimensions of the data. That all comes as a cost, and the private sector in particular are very commercially conscious.
Yeah, of course. One final question, I think, before we wrap up for today. For you, Pravesh, do you use any near real-time data in your fin peril models? In fire, flood and cyclone risk mapping, how many years of previous data do you take into account?
Yeah.
Is it more the better?
Yeah, that's true. Yeah, I think there's probably I think the models are trying to model the perils, and so it uses the science behind what drives those risks. And then you have events, which are kind of a representation of that. But given that we're talking about pretty low frequency, high severity events, you can never have enough events to really tell you what the true risk is. And so that's why there's the benefit of using models that consider the science, consider the climate to model that out. So in terms of information that we use, it's close to real time in terms of the physical asset data that we use. In terms of actual event history or previous years of experience, we're constantly reviewing that. So clearly the recent floods that we saw, we review our flood model to make sure that it still holds the test of time and reflect that as we go along. But that's not to say that we necessarily use a defined set of years of experience to form a view on our models, because in reality you need to have the best view of it, you need to combine recent experience in natural perils with the actual science that drives it, because some of these events we're modeling events that may not have happened before or haven't happened for 50, 100 years. So you need to kind of blend the two approaches.
Okay, tremendous. Well, look, our hour is up, so I'd like to thank both of our presenters, Michael Dixon from Geoscape and Pravesh Connor from Affinity. I think it's been a fascinating presentation and really opened my eyes, at least, to all sorts of possibilities. So I think you'll agree it's been a fascinating webinar. So if you'd like to hang on for just one more minute, there's a survey we'd love you to take, just as a bit of feedback, if you could. So thank you once again, and we'll see you next time.
Thanks.